Hello friends, you are watching AMS Entertainment YouTube channel. Today I will give you a brief introduction of oxidative phosphorylation. That what does it mean by oxidative phosphorylation? Why we call electron transport chain is oxidative phosphorylation. First of all, I will tell you that we have two main powerful electron donators, NADH2 and NADH and FADH2. NADH2 mainly gives its electron to complex 1 and FADH2 mainly gives its electron to complex 2. The complex system are different types of, you can say, a housing system inside or on the inner membrane of the mitochondria. This is known as submembranous space and this is known as matrix. This is the rough structure of mitochondria which produce energy. This is the powerhouse of the cell. So when NADH gives electron to complex 1 and FADH2 gives its electron to complex 2, these electron comes in a series of a chain reactions. For example, from complex 1 to complex 2, from 2 to 3, 3 to 4, 4 to 5, and in such a way this oxidative process leads to phosphorylation through complex 5. Okay, now when the electron when NADH give electron to complex 1 and FADH2 gives electron to complex 2, they both supply their electrons to complex 3 through you can say a mobile component, a carrier known as coenzyme Q. Coenzyme Q will bring electron from complex 1 to complex 3 and from complex 2 to complex 3, and then from complex 3 to complex 4, another carrier known as cytochrome C will carry these electrons to cytochrome 4 in order to react these electrons with oxygen. Oxygen is the final acceptor of electron and the most powerful acceptor. And then here the oxygen reacts with those electrons and the free protons like this to form water. Okay, this is the final product of electron transport chain. And now this is oxidation. Then where is phosphorylation take place? Now there is something very interesting point, that how the phosphorylation actually take place. Here in the matrix we have a lot of hydrogen free protons in the matrix region of mitochondria. Now these electrons, when passed through different types of complexes, these are energetic electrons, and when they pass through complex 1, this whole complex become energized. When these electrons pass through complex 2, the complex 2 become energized, and same is the case with 3 and 4. Now when these complexes become energized, that energy is used because this membrane is permeable to proton. The proton cannot pass through this direct membrane. This membrane, the outer membrane is permeable, but the inner membrane is not permeable for the protons to get out of the matrix. So these proton uses that energy by the electrons to that when the complexes are energized, they use this energy to get out the proton from the matrix to the intermembranous space. This is intermembranous space of the mitochondria. Now when we have more electrons coming through this process, we have more proton to get out to the intermembranous space. Now at this process, the outing of proton from the matrix to intermembranous space is only take place at complex number 1 and complex number 3. This naughty process doesn't take place at complex 2. Okay, now if we have more electron, now more electron coming through this process, we have more energy and our complexes will be more energized, and if our complexes are more energized, more proton will get out to the intermembranous space. Now the main point is, where is phosphorylation actually take place? Now I can tell you another process, that for example this is complex 5 and we have more protons outside, as I have already discussed it, that through the energetic complexes we get out the protons from the matrix to intermembranous space. Now this is a gradient. We create different gradient, concentration gradient and chemical gradient. Now this is actually the potential energy in the intermembranous space. Now we have complex number 5. Complex number 5 has different types of proteins, and it has two parts. In one part they have free phosphates, and in the other part they have ADP. ADP actually comes through cytosol from a special type of gate. From this gate, actually ADP comes from cytosol, and from cytosol it actually comes to this complex number 5, that portion in which we have free ADP. Now through complex number 5, the protons can only enter to the, for example, in the intermembranous space there is high concentration, and inside the matrix there is low concentration. Then proton will always go from the higher concentration to a lower concentration. So when the protons come through complex number 5, here is a channel to be rotated. When this channel rotates, the ADP and the free phosphate mix together, and when we know that ADP reacts with free phosphate, it leads to ATP. ATP is energy currency. So when ADP and phosphate, when combines together, it forms ATP, and ATP falls down inside the matrix. And this ATP cannot come out through this membrane because this is permeable. This ATP again goes through this channel, that channel through which the ADP comes from cytosol. Okay, now in such a way the ATP is formed and then get out of the special transport system to go to the cytosol and use it from different type of uh, reactions, or different types of activities. Now in this way, this oxidative process actually leads to formation of ATP, and that is oxidation, and this is phosphorylation. So in this way we call the electron transport chain as oxidative phosphorylation. Okay, thank you very much. Kindly give me a feedback, as I am new to this field. I'm not new in the medical field, but I'm new in the YouTube, so please encourage me and also subscribe to my channel. I will upload more simplest videos so that you can have a crystal clear concept on the medical processes. Thank you very much.